Particle projectile motion, BPM Part 1, Graphs. The first scenario explains when an object is dropped from the building and upwards is taken as positive. You will start with your initial velocity being 0 because it's dropped. These are the three different types of graphs. I want you to by heart them because you would be able to apply them in any scenario that you're given. This one is an object thrown up and caught. Upwards is taken as positive gain. When it reaches maximum height, your velocity is 0. These are the three graphs. I want you to by heart them as well. This is an object thrown down from the height. This is similar to an object being dropped. You will start off with your velocity initial being 0 as well. The next scenario is when an object is thrown up and lands at a specific point, which in this case is a bowling. All these scenarios are upwards taken as positive. You will start with your velocity initial being 0, and at this point, maximum, your velocity will also be 0 until it lands at the point. Here are the three graphs again. This is an object thrown up from a height. Velocity initial 0, maximum is also 0. Your three graphs. This is a bouncing object. So as you can see, the ball goes from there, it bounces here and then goes down. Here is your three graphs. All these graphs have different scenarios and any one can be asked. Thus, by hearting them and learning them to the best of your ability is the best you can do, and just change the values that are given. Just a little bit more background on graphs. You have your velocity time graph. The area below is your displacement. The gradient is your acceleration. Your displacement time graph, the gradient is velocity. Or you could use this little trick. You write displacement, velocity, acceleration. If you go toward your left, it's area. If you go toward your right, it's gradient. An example of this would be, take velocity. Velocity, if you move toward your area, it'll be displacement. If you move toward your gradient, it'll be your acceleration. So for velocity time graph, your area is displacement, and for your velocity time graph, your gradient is acceleration. And it works in all the scenarios. Also, when you look at a graph, if it's steeper, you're moving away, and if it's gradual, you're moving towards.